So good morning. It's a great turnout for an 8:30 a.m. session on Thursday morning. This session is about what's new in Windows 8 deployment. My name's Mike Niehaus. I'm a Senior Product Marketing Manager for Microsoft, responsible for enterprise Windows deployment. In this session, we really want to talk about what's changed with deployment when it comes to Windows 8. So we're not really going to talk about really what's new with Windows 8, except from the perspective of how does it impact your deployment processes. We want to make sure that we understand how the lower level deployment tools have changed to add support for Windows 8, and then how the products that are built on top of those, including MDT and Config Manager, have also added support for Windows 8. But as we go through this, we really want to look at kind of the more technological pieces of this to figure out just how those impact the deployment process, look at the images, look at the operating system details to figure out how this is really going to change things. So to start off with, it's probably good just to give you an idea of the changes in the operating system itself. First, from a size perspective. It's, generally in the past, every Microsoft operating system that's been released has gotten bigger. And as a result, it's required more resources. It's required more CPU. It's required more disk space. It's required more memory. This is an exception to that. Windows 8 actually is smaller than Windows 7. If you look at the image, it's about 1.96 gig for Windows 8 compared to 1.97 gig for an image of Windows 7. So the operating system itself has shrunken by a little bit, even when expanded and placed on the disk. So that's a good thing. The working set size, the amount of memory that's taken up when the operating system is running, has actually shrunk. So we've tried to put in a lot of effort to reduce the amount of resources that Windows is using. That would make sense because we now want Windows to run on lesser powered devices, things like Intel Atom-based tablets and Windows RT. We need to be able to get the footprint and the resource requirements of Windows down to run on these lesser powered devices. So as a result, that basically means if you have any system that's able to run Windows 7 today, it's a pretty good bet that it can run Windows 8 because you're not going to need any additional disk space, memory, CPU power to run it. That's a good thing. But from a deployment perspective, we wanted to see, well, just exactly how did the technological changes in the tools impact just the speed of the deployment. So just to run some tests, we used a virtual machine, actually a machine running in my office, to create a virtual machine and deploy Windows 7 to it. See how long that takes to do a bare metal deployment. It takes about 15 minutes from the time you boot into Windows PE and click the Go button, in the case of MDT, until the time the operating system is fully deployed. If you do the exact same process, exact same hardware, exact same virtual machine with Windows 8, it takes about 10 minutes. So we've managed to shave about 5 minutes off of that end-to-end process time. So there are a variety of reasons for that. Some of it's networking, some of it is just improvements to the storage stack, some of it's improvements to the imaging tools, just a variety of improvements through the overall stack. But we really expected a lot of that to be a result of changes in Windows 8 itself. Just for comparison, we wanted to try the exact same thing using the new deployment tools. So using the new version of Windows PE, the new version of ImageX, the new WinGAPI, all the underlying pieces that perform the deployment process. But deploy Windows 7 using those new tools. When we do the same thing with Windows 7 as we did with Windows 8, it also now only takes 10 minutes. So we actually get the performance benefits from just moving to the new tools, not from the new operating system itself. So generally then when people ask, well, should we move to the new deployment tools in order to deploy Windows 7 if we're not yet ready for Windows 8? Yes, absolutely. Those new tools are going to be more performant than the old tools. We'll be able to deploy the same OS faster, and we'll get some additional benefits that we'll talk about as we go through here. So the images get smaller, the installation time gets better. If you've ever done an in-place upgrade, which isn't very common in enterprise scenarios, but we keep working on it, trying to get it better, trying to get it faster. If you try to do an upgrade from Windows Vista to Windows 7, way back when people were actually doing that, that upgrade process would take about 30 minutes. And it would only go up from there. The amount of time taken would go up based on the number of files, the number of apps, just the overall size of the operating system, to the point where it could easily take 4 to 5 hours to upgrade a fairly typical Windows Vista install to Windows 7. Well, that was kind of discouraging. Maybe it was okay for your home machine, but it's not something that you would do in an enterprise because, well, it would be faster to refresh the machine, capture all the user state, wipe the machine, lay down a new OS, reinstall the apps, pull all the user state back down. You could do that faster than the 4 to 5 hour upgrade time. So they did make a whole lot of improvements in the Windows 8 upgrade process. Now you can only upgrade from Windows 7, so this would be a Windows 7 to Windows 8 upgrade. That upgrade now takes about 20 minutes. But it doesn't really go up that much as you add additional applications and additional data. Even if you have millions of files, maybe your entire MP3 collection on the system, and you do an upgrade, it's still going to take under an hour to do that upgrade. So it's much more practical to do an upgrade, but still enterprises don't generally do it. So we'll continue to work on that. We'll continue to make it better and try to get it to the point where you would consider that as an option for moving to new versions of operating systems. But at this point, we still expect that most customers are going to go through the standard refresh cycle of capture the user state, install the new OS, put the state back. So most of the benefits that we're talking about here are coming from the new version of Windows PE. We'll look at that in a little more detail. The interesting comparison is if you go back to the Windows Vista install time, it actually takes about a half an hour to install Windows Vista. So you can see that over time we've improved this installation process even as the operating system size has stayed the same. So we started off with 30 minutes way back when, 7 or 8 years ago. Got it down to 15 minutes with Windows 7. Now we're to 10 minutes with Windows 8 to get the operating system up and running. Now, you can run Windows 8 on existing hardware, but there is one exception to that. There is a new hardware requirement in Windows 8 where it will only support machines that have processors that support NX, SSE2, and PAE instruction sets. NX is a no execute bit. It was something added around the XP SP2 timeframe to provide hardware buffer overrun protection. No execute bit basically meant that no one could shove data into the memory of the machine and tell it to execute. So that was added in some of the earlier Pentium processors, so way back when, but there are still machines being manufactured today that don't include that support. Very low-end machines, Celeron-type machines, things that you typically don't see in enterprise environments. That doesn't mean they don't exist. So if you do try to deploy Windows 8 to one of those machines, it won't boot. You'll get a blue screen saying that this machine doesn't include the necessary processor support. That would also be a reason why not to use the new deployment tools. If you're deploying Windows 7, Windows 7 would support those machines. All right, where were we? We were talking about the hardware requirements for Windows 8 and the instruction set requirements that need to be supported by the CPU, which are NX, SSE2, and PAE. Generally, if you just look for machines that support NX, the other two will come along with it, so they're a full set. There are some blog entries out there on blogs.technet.com that have been posted that explain how to inventory that. So like if you're using Configuration Manager, you can run the Core Info tool from sysinternals, which will output that information. It parses that information, stores it into WMI, and then you can collect that using Configuration Manager and look for machines that will support that. So that's important for Windows 8 to make sure that your Windows 8 hardware or your Windows 8 operating system will boot on the hardware, but that also is important for any use of Windows PE 4.0. Windows PE 4.0, the new version that's come out with Windows 8, has the same requirements. So let's say you wanted to use the ADK, the new set of deployment tools, to get these faster deployment speeds to deploy Windows 7. Well, you're going to have the same hardware requirements as Windows 8 because of using Windows PE 4.0. Same applies for System Center Configuration Manager 2012 SP1. It requires ADK. When you go to ADK, you now need to have hardware that supports these instruction set capabilities. The other gotcha that's affected some customers is VMware. Older versions of VMware don't include those processor features in their emulation. So if you're running VMware 5.0 or earlier, the new version of Windows PE won't boot on it. Windows 8 won't boot on it. Windows 8 isn't even supported on it, so you need to upgrade to at least VMware 5.1 to get that to work.
Actually, I was on the customer side where we were using VMware 8, and it was moving to VMware 4.0. You have to upgrade to VMware Workstation 9.
Yeah, on the workstation side, there are some additional requirements. 8.0 won't work, 9 will work. So just make sure that you're running a version of your virtualization software that actually includes support for Windows 8. In a lot of cases, that's because of these new processor requirements. They need to emulate those capabilities. Next item on the list is BitLocker, and this is one of those changes that really can improve the amount of time that it takes to deploy an operating system and turn on BitLocker at the same time. With Windows 7, when BitLocker initially came out, the process you needed to go through was you needed to fully partition and format the disk, then deploy the new OS, then turn on BitLocker. BitLocker would then encrypt every sector on the drive, and that process would generally take, depending on the drive speed, somewhere around 2 hours for most spinning disks. SSDs, of course, would be faster. During that time, the machine wasn't particularly usable because it was too busy doing this encryption, and it would mark almost all the disk space on the system as used because it was in the process of encrypting it. With Windows 8, and really with the new version of Windows PE 4.0, now we can enable BitLocker and first tell it to only encrypt used disk space, not free disk space, which improves the speed greatly. And then also we can do that in Windows PE before the OS is even installed. So the process that we would now use is format and partition the disk, turn on BitLocker, telling it to encrypt only used space, which there really is none at this point because the disk is empty. So turning on BitLocker takes about 3 seconds. After that's done, we can then apply the operating system to the encrypted disk. The operating system bits get encrypted on the fly without any real noticeable overhead in the deployment process. We then boot into the new OS, and all we had to do at that point is turn on the protectors for BitLocker. Add a TPM, add a pin, add whatever protectors you want, and the machine is then fully deployed. So this can cut hours off of your deployment process if you're deploying machines with BitLocker. Very nice, very easy to do. Because it's really dependent on logic that's been added in Windows PE 4.0, you can also do this with Windows 7. All you need to do is move to the new ADK, move to the new version of Windows PE, and you can do the same offline BitLocker pre-provisioning even for your Windows 7 deployments. In the case of Windows 8, there are a couple of other enhancements in BitLocker which are useful. One is that you can automatically unlock a BitLocker protected machine when it's on a trusted network. So by combining some WDS capabilities with certificates and DHCP, you can indicate to the hardware, at least for UEFI enabled machines, that you basically give them a mechanism to detect that at boot time the machine is on a trusted network. And in that case, you can set up the protectors to do, well, maybe just don't prompt for a PIN. But if the machine is on an untrusted network, maybe you plug it in at your local coffee shop, then it can prompt to enter your BitLocker PIN before the machine is allowed to boot. So that's a new feature that's been added. You also now have the ability for standard users to reset the PIN, which was a restriction in Windows 7. In order to change the PIN for BitLocker, you had to be an administrator of the machine, but that's no longer the case. So the big thing from the deployment perspective is the pre-provisioning support. We can shave hours off of the process, but there are some other additional improvements that may make BitLocker a better solution for you compared to what was offered in Windows 7. Next item, UEFI, which I know there's a session tomorrow morning that Frank Pinto is giving. We'll basically spend the entire session talking about BitLocker, or not BitLocker, about UEFI. So we want to do an overview at this point. Why is UEFI really important? Well, for older hardware, if you've ever tried doing, say, a Windows 7 deployment to a current generation laptop using UEFI, it really didn't help much at all. It had lots of pains and not a whole lot of benefits. But with the new Windows 8 logoed machines and the new version of UEFI, 2.3.1, we get some interesting benefits. One is speed. The machines are going to be much faster to initially post. The power on self-test process will be very quick. In fact, the logo requirements for Windows 8 say that a machine with an SSD in it must post in 2 seconds. So from the time you hit the power button until the time the operating system starts to boot, 2 seconds. If the machine has a TPM, they allow another 0.2 of a second to initialize the TPM. So in that case, it's 2.2 seconds, but still very fast. That actually causes some interesting side effects because the OEMs, typically when you push the power button to turn the machine on, they show their logo on the screen. And they can't show the logo until it's gone through some of the initial power on self-test processing. So they complain that with UEFI 2.3.1 and this 2-second post requirement that you can't see their logo for long enough. It might only flash up on the screen for a second before the operating system would start to boot. So we had to design into Windows the ability to continue to display the OEM's logo even while the operating system is booting behind it. So what you would actually see on a UEFI computer is the OEM logo will show up, and then suddenly you'll see the spinning Windows wheel underneath it, which indicates that the operating system is booting. The operating system itself can boot much faster because it's using UEFI's 32-bit, 64-bit large buffered I/O capabilities compared to the old legacy BIOS int13 disk calls, which were all 16-bit code and could only read 4K at a time, which was really silly considering the capabilities of the hardware that we had. So the operating system can boot much faster. The post process is much faster. Overall, it's just that much faster. I have a Surface Pro machine up here, which unfortunately won't actually boot, won't actually display the video. I mean, it boots fine, but you couldn't see it while it's booting. So if we booted that machine up from a cold start to the point where you can log on, only takes about 7-8 seconds. It's extremely fast. First to go through the post, then to get the operating system loaded, Control-Alt-Delete, log in from there. So very, very quick. That would be the main benefit of moving to new machines using UEFI 2.3.1. Now, there are some other gotchas for UEFI. One is that when you're running a machine in native UEFI mode, so to get these benefits, you can't do cross-platform deployments. You can't run an x86 operating system on a UEFI native x64 machine. You can only run a 64-bit operating system. That means also that you have to use x64 boot images. So if you're using Config Manager and using x86 boot images to deploy an x64 OS, you won't be able to do that if you're doing native UEFI. Now, UEFI machines in the past have always included legacy BIOS emulation, which enabled you to run older operating systems and enabled you to do these cross-platform OS installs. But there are now machines coming out, like the Surface Pro, that are UEFI only and don't include that legacy BIOS support. Without that legacy BIOS support, you really can't install earlier versions of Windows. Only Windows 8 supports UEFI native, the Class 3 UEFI systems. and well, you can't do really any older OSs. You can't do the cross-platform support. So be careful with these Windows 8 logo machines if you're going to deploy an earlier operating system to them. Make sure you understand, are they a Class 3 UEFI machine, which is UEFI only, or are they a Class 2 UEFI machine, which includes that legacy BIOS emulation and could then run older operating systems. It's important to recognize, too, that UEFI systems require a different disk format and also require a different partition structure. So instead of creating an MBR disk, we now need to create a GPT disk. We need to create a 4-partition structure. Actually, you could create only 3, but you really want to create the 4th one if you're ever going to turn on BitLocker, because if you don't, BitLocker will force you to create the 4th one before you'll be able to actually turn it on. So the first partition, the EFI partition, is a fairly small partition, not very big, usually about 500 meg. It's a FAT32 partition. EFI is only able to read FAT32 partitions to boot, so it reads the boot files off of there. Those tell it where the operating system resides. The operating system is on the largest NTFS partition. It boots from there. There's also a Microsoft Reserve partition, and then the Windows RE Tools partition, which is used for BitLocker recovery, so that one needs to be there as well. If we look at that, actually see if I can wake up my machine. If we look at my system here, let's just bring up a command prompt. If we go into disk part, and list the partitions, you can see on my system that we have 4 partitions. The initial recovery partition, 300 meg, so it's not very big. That contains the recovery files for BitLocker. System partition is basically the boot partition, 350 meg. That's the FAT32 partition. The Microsoft Reserve partition is always 128 meg. And then the rest of my disk is for the operating system itself. So that's the type of structure that you'll always see. And as a result, you'll see in the deployment tools that they will have steps in them to create this partition structure. If we look at this in MDT for light touch deployments, it will automatically do this when it detects a UEFI system. In the case of Configuration Manager, there are actually different format and partition disk steps in the task sequence with conditions on them that say, is this UEFI, is this not UEFI? Where it can get a little tricky is, let's say you have a UEFI system that also supports the legacy BIOS emulation. You have to make sure you boot it into UEFI mode or legacy mode. So if you're used to pressing a key to get a boot menu and then choosing an option to boot from, maybe you have a USB key or a CD that you've inserted to boot the machine, there could be 2 choices for those media items. One that boots using legacy, one that boots using UEFI. However you boot, that's the type of operating system deployment you're going to do, UEFI or non-UEFI. For older UEFI machines, because they've been making laptops with UEFI firmware for probably about 3 years now, you probably haven't even noticed because you're just running it in that legacy BIOS emulation mode. They haven't included historically PXE support. So if you wanted to PXE boot a machine and have it boot using UEFI, you were completely out of luck. I mean, it just would never work. It would always do legacy BIOS support using PXE. Now with the new UEFI 2.3.1 machines, PXE is actually supported using UEFI, but you do need to have the latest WDS support in order to support that, especially if you're using x86 machines like the Intel Atom-based devices. So UEFI is something that you'll have to get used to. It's especially important for the new Windows 8 logo required or logo certified machines. For Windows 7 machines, it's not as big of a deal. If you look at another scenario, let's say you have a machine that's running Windows 7 today that you've deployed using the legacy BIOS emulation, and now you want to deploy Windows 8 to it, so you want to refresh it. There's no good way to do that in place, because that requires changing the partition structure, requires changing the drive type, it requires changing the BIOS configuration. You can't really automate that effectively as part of a refresh process. So if you wanted to do that, you would have to capture the user state off to the network, then basically do a bare metal deployment back to that machine and restore the user data back down, because you'd have to repartition, reformat along the way. The other benefit that you get out of UEFI is security. UEFI enables secure boot, where secure boot is really defined or designed to make sure that the operating system can be protected until it's up far enough to protect itself. So using this, we can make sure that the boot files have been signed with a valid certificate and they haven't been tampered with. It's very important to make sure that something like this is in place to prevent rootkits, because rootkits hook in at that lowest level before the operating system is really up and running. So this is a key security addition that we've added. On x86 and x64 machines, you can turn this off if you want, but it can't be turned off using tools, because if you could turn it off using a command line utility or something like that, then you could defeat this protection. But you can manually go into the BIOS setup screens and turn off secure boot and then use other operating systems on the device. Since only Windows 8 and the most recent Linux distribution support secure boot, using older operating systems would be problematic if you didn't have a way to turn this off. So you can turn it off, and once you have it off, then you don't have to worry about that. You can then install whatever operating system you want. Next item on the list then, Windows Store apps. And I did a session, was it yesterday or the day before, on Windows Store apps. How many of you were in that session? A few of you. So we'll give the 5-minute version of that 75-minute session. Basically, Windows 8 apps are completely different than any app that you've deployed before, because they now are always installed per user. They are effectively a zip file, so they're all packaged up into a zip file where Windows will download that zip file, extract the contents, and then register the app for the current user. It doesn't require admin rights to do that, so any user can install an app. You generally would install these from the Windows Store, but you can sideload them from another location. So anytime you hear discussions around sideloading or enterprise app stores, you're talking about installing an app from a location other than the Windows Store. So that's installation. Provisioning is a separate process. Provisioning enables you to register an app on the computer so that it automatically installs for each user on the machine. So if you wanted to put apps into your standard golden image, you can do that through this provisioning process so that they always show up for every user that logs on. Doing that provisioning does require administrator rights and does require enabling sideloading. The requirements to enable sideloading, you need to be running Windows 8 Enterprise joined to Active Directory, where sideloading is automatically enabled, or you can install a separate sideload product key using slmgr.vbs/IPK, and then the product key. It installs like a Mac key, where it has to go out to the internet and activate with Microsoft. But it isn't a Mac key. This is completely separate from operating system activation. This is basically feature enablement to make this side-loading capability possible. There's also a registry key that needs to be set to say allow all trusted apps, which you can set that using group policy easily enough. And the app will be signed with a certificate. That certificate also needs to be recognized by the operating system as something that's been trusted. So whatever cert was used to sign the app, if there's a trusted root certificate that goes along with that that isn't yet on your machine, you may need to deploy that to the computer in order to run the app in that way. There are PowerShell commandlets to do installation. There are PowerShell commandlets to do provisioning. You can also remove the built-in apps if you wanted to. All of that can be done using PowerShell. There are also some DISM command line options to do the same thing. Now, if you wanted to implement your own enterprise app store to deploy these apps inside of your own enterprise, You can do that using either System Center 2012 Configuration Manager SP1, which includes the ability to install these applications, along with their app catalog, which is a web page where the user can go and request them. Or you can use Windows Intune. Windows Intune also knows how to install Windows Store apps and provides a modern app, the company portal, where you can go and request apps that should be installed on the machine. So those basically are the enterprise app store options that we provide. There are also Codeplex projects that you can do for free that kind of show the same thing. There are also APIs that you could use, or just using any standard software distribution tool that can run as the user, you can run the PowerShell commands yourself to register these applications. The big requirement for these is, in order to do any of these side-loading operations, to set up your own enterprise app store, you need to have the AppX files, the installation files for these applications, because those are required for all of these commands to work. If the app's only available in the store and you don't have the install files yourself, well, then the only option is to install it from the store. In order to install it from the store, you need to log into the store with a Microsoft account. Microsoft account's just a new name for a Live ID. So you log in, you install the application, and then it's available to that user. Because it's a per-user installation, if you install it for one user, log on for another user, it's not going to be there. You'd have to install it again for that other user. It is actually single instanced on the machine, so there would be one folder that has all of the applications, and then as each user installs it, they just have a pointer to that single instance store. As soon as no user has that application anymore, the oldest ones can be deleted. The operating system automatically cleans those up. The other gotcha that usually goes along with this is, let's say that you have installed apps into your image. They can be Windows Store apps. They could also be desktop apps. When you install them, they put icons onto the start screen. Those icons will generally be added to the rightmost part of the start screen, and they just keep growing out to the right. If you want a particular layout, so if you want the icons to be arranged a certain way when you deploy the operating system, you can do that, and there are some processes documented for that. So you would have to install the OS, install the applications, arrange the tiles the way you want it, then sysprep it. When you sysprep the OS, it'll generate an apps folder layout.bin file that contains the portable start screen layout. You can then copy that into your image, and when you deploy that image, it will automatically use that layout when the user logs on for the first time. Now, that doesn't prevent them from rearranging things after they've logged on, but you can at least set the initial layout for them by going through that process. So we've got some TechNet articles and Deployment Guys blog postings that talk about how to do that. So understanding how these work and understanding the processes that you need to go through for this really are important things with Windows 8. Apart from UEFI, one of the biggest changes that you would see in the deployment process itself. Next item on the list, Windows to Go. How many of you have seen a demo of Windows to Go? Not quite the majority, so I can't skip that one. So I guess we should probably do a Windows to Go demo. The basic idea with Windows to Go is that we can take a USB drive, we can install Windows onto it, and we can boot it from that USB drive. So rather than installing Windows onto the hard drive itself, we can run it completely from that USB key. Now, the challenge with that is we had to be able to support moving that USB key from computer to computer, so we had to add some additional plug-and-play logic to handle that. We also need to be able to provision those USB keys. How do we put the operating system on that USB drive in the first place? So we've got some wizards and tools to do that. And beyond that, it's really just a question of, well, what are the requirements for the drives themselves? You can't use just any USB key. We require a USB key that won't melt down because of the level of activity, will have a reasonable lifetime because of the level of activity of running an operating system off of it, and also it has to report itself as being a fixed drive instead of a removable drive because we need to partition it. We need need to put multiple partitions on it so that we can boot these drives either on UEFI or non-UEFI systems. So there are a list of about 6 or 7 certified USB 3.0 drives, SSDs, USB keys, hard drives where you can put Windows onto it, and they will boot up just fine and work as Windows to Go drives. If we switch over to my laptop, get back in here again. If I look at the drive on my system, you can see my current hard drive, 148 gig. If I insert my Windows to Go stick into the system, it won't actually show up. It's been configured to not mount itself by default. So we don't want to get confused if we're dealing with the built-in hard drive or the USB key. What we do have on a Windows 8 system, if we search for Windows to Go, under Settings, we have some startup options which are tied to the new Windows 8 boot files. So we can tell it, automatically look for these USB keys, and if you find them, go ahead and boot from them instead of from the hard drive. So then I don't need to hit the magic key to select a temporary boot device to boot from my USB key. I can just reboot the machine, and it will automatically go into the USB key. So let me do that. So I'll restart my computer. Hopefully the video will continue to display externally. Let's see if we can force that just by keeping the lid closed. The scary thing is I'm starting to get used to the flashing lights on the wall. Oh, I need to put in my BitLocker password. And then the operating system will start to boot. If this were booting using UEFI, instead of seeing the Windows logo with the spinning wheel underneath it, you would see the OEM's logo with the spinning wheel underneath it. But that's a good way to tell if this is a UEFI boot or not. In this case, I must not have removed the drive cleanly the last time, so it's going to do a check disk real quick. Hopefully that doesn't take very long. And then the operating system will boot up from there. So generally this doesn't take that long. The operating system will boot up fairly quickly, even though it's running from a USB key. So what you end up with is a perfectly usable USB key, a perfectly usable version of Windows running from that USB key. Now, unfortunately, the scan disk is going to take longer than I care to sit and wait. So we'll come back to that in a minute and see if it finishes up. So the process of provisioning those, if you're using, well, first this requires Windows 8 Enterprise. This is a requirement because of some of the licensing restrictions. It's not so much a technology challenge, it's more of a licensing challenge. If you have software assurance for Windows and are using Windows 8 Enterprise, you can create these Windows to Go sticks, and they're provided basically as part of your software assurance benefits. So that's easy enough to do. The question is then, what's the technical process that you need to go through? There is a built-in wizard on Windows 8. If you search for Windows to Go, you can run the wizard to create these. It will ask you for your USB key and your WIM file that you want to apply to the disk. If you're using System Center Configuration Manager, it also includes a self-service capability. So the idea would be that your users acquire these USB keys, either purchase them themselves or they're given to them by the company, whatever the case may be. They can then go into the Software Center in Config Manager, say that they want to run Windows to Go. It will run the same basic wizard, running elevated because Configuration Manager is executing it for them. Ask them to insert the USB key, and it will automatically install the Configuration Manager task sequence for a pre-staged media onto that USB key. So you then have a USB key that when it boots up for the first time runs a Configuration Manager task sequence. that can join the domain, apply patches, set up direct access, encrypt the drive using BitLocker, all of the necessary requirements, all the same steps that you would go through with your typical OS deployment task sequence, but instead it would be running from the USB key. So a very convenient way of setting these drives up using that configuration manager support. Now, the other option that you have, if you're going to do a lot of these, you probably don't want to run through that wizard over and over and over again. You can also do that once to create a key and then send it off to the manufacturer and say, manufacture me 1,000 of these and send them back in a box. So a lot of the vendors for these will mass produce them to make that a simpler process. Okay, next item on the list, Hyper-V is a new feature in Windows 8 on the client side. So we don't need to have a server anymore to be running virtual machines. To support this, we do need to be running Windows 8 64-bit. We need 4 gig of RAM or more just to make it useful. You can't run any virtual machines if you don't have enough RAM to run them. This does require hardware-assisted virtualization, which is supported by any of the Intel Core processors. While she's talking, we'll switch back over to the BitLocker Windows to Go. Yay. So my Windows to Go did finish its check disk. It then prompted me to type in my BitLocker password, which I've done. I'm not sure if the video is going to show up again until it gets into the full operating system, so we'll give it a minute here just to continue booting. So it probably takes about 30 seconds to boot Windows up on that USB key to the point where we can actually see the video. There it is. Now I can log on, which is a separate log on from my other system, which actually shows one of the other Windows 8 changes is that we can log in with Microsoft accounts with live IDs. It warned me that before I must have removed the USB drive while Windows to Go was running. It's telling me don't do that. Good suggestion. But now we have basically a full Windows installation that you really can't tell it's running from a USB key. If we go to the desktop and bring up Explorer now and look at the computer, we see the USB key as a 32 gig drive, but we don't see the hard drive on the system. By default, it's not mounted again, so you don't get confused. You could, if you had admin rights, still go into the disk administration tool and assign a drive letter to it if you really wanted to get to it. But by default, it's configured with basically a SAN policy that says don't assign a drive letter to that. But we could do that if we really wanted to force it. If it's BitLocker protected, yes, you would have to provide the necessary unlock information. In the case of TPM, that would be problematic because you can't share a TPM between operating systems. It would be owned by one or the other. But if you just had a simple password requirement, or if you wanted to use a recovery key, you could do that. But yeah, that would be an issue. So let me reboot this machine back into the full OS, because eventually I want to be able to show Hyper-V. While that's happening, let's talk a little bit more about Hyper-V. So we said 64-bit, 4 gig RAM or more, hardware-assisted virtualization. Those are basically standard requirements, exactly the same as what you would see on a server operating system. Any Intel Core processors will support that. There's also a requirement for second-level address translation. That doesn't exist on the server. That only exists on the client. And the reason it exists on the client is because of the video cards that are used on client machines, desktops, laptops, etc. If you were to take a high-level video card, high-end video card, say a card with a gig of RAM in it, and put it into a Hyper-V server, your Hyper-V performance would be awful because of the number of memory interrupts that are happening, the number of page faults that are happening because of that video card. So on the client side, because those types of video cards are very common, we require this second-level address translation support to avoid all of those page faults, to give us decent Hyper-V performance. So you can't even install Hyper-V if your hardware doesn't include that support. So if you try to enable Hyper-V on a system and it won't let you, if it's grayed out, that's because Windows didn't detect the ability of the machine to do second-level address translation. The tricky part about that is some machines today are sold with processors that support second-level address translation, some aren't. So in order to figure that out, you can use a tool like Core Info from sysinternals, or in the case of MDT, there is a WMI query that will work within Windows PE 4.0 that will query Win32 processor and tell you, does this machine support SLAT or not? If you were to try to figure this out by looking at the AMD or Intel websites, it's a little trickier because, well, they don't use the same terms. You won't see Intel call this SLAT. You'll see Intel call it EPT, Enhanced Page Tables. AMD uses a different term for it, and I can't even remember what AMD's term for it is, but basically it's the same capability. So the capabilities required, detecting it is something that we can do once we have a Windows 8 operating system or Windows PE 4.0 on the machine. Once that's in place, we can do that. You can determine that using Win32 processor, the WMI class, or you can also do that using the Core Info tool that we talked about already. Have to give my machine a minute to come back up again. We'll come back to Hyper-V in a minute. Next items in the list, refresh and reset your PC. These are basically the new Windows recovery environment capabilities that were present in Windows 7 that enable you to take your existing operating system and roll it back to a previous state. There are two ways that that can be done. One is going to retain nothing. The other is going to retain your data, your accounts, and the modern Windows Store apps. So you have to kind of be careful when you do this because there are going to be things that are lost in this process. You're rolling your operating system back to an image, a WIM file, that's stored on the system itself. In enterprise cases, this isn't something that we typically see enterprises set up because let's say you have a deployment process where you're using MDT. And as part of that process, you deploy an operating system image, you deploy the drivers that are needed for that machine, you install applications, and you do any other customization that's needed, like joining Active Directory. If you then take that same WIM and stage it onto the hard drive as a recovery image, and then use either of these options to roll back to that WIM, what are you going to lose? You're going to lose all the drivers, you're going to lose all the apps, you're going to lose the domain join, you're going to lose all your customizations. So really what you need is an image that contains all of that stuff, that's been captured from the point that the machine was deployed, which there are some command line utilities that could be used to do that machine by machine as you go through your environment, basically as part of the task sequence, but it would take a long time and it's generally problematic overall. So we don't see this being used quite as much in enterprise situations. It's primarily an OEM recovery scenario. Not that it can't be done, but just keep in mind that the image that you're using needs to have all the necessary pieces in it so that when the user rolls back, they aren't left with a vanilla Windows install that wouldn't be useful for them. Let's look a little bit more at Hyper-V while we're here. Ignore some of these pop-ups. So Hyper-V running on Windows 8 looks just like Hyper-V running anywhere else. In this case, I don't have an external drive attached to it, so it says it can't connect to that. That's fine. But it's easy enough to create a VM, connect to a VM, same basic functionality that you would expect there. One of the other nice things about Hyper-V on Windows 8 and also on Server 2012 is that it fully supports PowerShell. So I can run PowerShell commands to do something simple like new VM. With no parameters, it creates a new VM. It assigns it a name, doesn't attach any disk to it, doesn't connect it to any network, so it's not a very useful VM. But there are additional commandlets that you could run to do that work as well. So just that one single command was enough to create a virtual machine here. And if we go in and look at the settings, we can see no drives attached to it, network's not connected, but otherwise it's a fully functional VM that I could turn on and it would attempt to boot. It wouldn't find anything to boot from, but it would at least try. So doing the types of image factory things that we had talked about over the past years, where you use virtual machines to help with your image creation process, become much easier now that we have full PowerShell support built into the operating system that can work with Hyper-V to automate the creation, turning on, and operation of these virtual machines. When we're done creating the image, we can just throw away the VM and start over again the next time. Very easy to do with PowerShell automation. Slates and tablets are another challenge for deployment, not because they're really any different. The biggest challenge is what they don't have. Usually they don't have a keyboard. Well, guess what happens when you initially boot up a machine to do a bare metal deployment using MDT? It's going to ask you to type in your password to connect to your deployment share. You can't type in your password without a keyboard, because Windows PE doesn't include any on-screen keyboard. So there's no way to type anything to do a deployment to a tablet without attaching a keyboard to it. It does include touch support, where the touch screen would behave like it had a mouse attached, so you could at least click on the screen, touch the screen with your finger and interact with it that way. So you don't need a mouse, but you would need the keyboard. You may also need to add a USB NIC, a network adapter, to the machine, because a lot of these machines only do wireless networking, and you can't do OS deployment over wireless. You could do it from USB media, you just won't necessarily be able to do it using wireless. So generally, people that are deploying these kind of have their toolkit, where their toolkit includes a USB keyboard that they can attach to the machine, either an Ethernet dongle, a USB Ethernet adapter, or a USB key so that they can do USB-based deployments. Now, a lot of these machines only have one USB port on them, so they also carry around a USB hub to connect these things to it. Otherwise, deploying them is pretty much like any other machine. You just need to keep in mind that some of them are going to be x86 only, some of them are going to be x64. Anything based on an Intel Atom is an x86 only machine. It can't run an x64 operating system. Anything that's based on an Intel Core could run either, unless, like we talked about before, it's UEFI only, like the Surface Pro, where it can only run a 64-bit OS because it doesn't include the legacy BIOS emulation that would allow you to run the 32-bit OS. So some gotchas there, but generally they're not too bad. Just the initial provisioning process may require some additional gadgets to make sure that you can pull that off. So let's talk about tools then. First, we have the Assessment and Deployment Kit. This is the new version of what used to be called the Windows AIK. It is still a free download. It's still out on the Download Center. You would download what's now a stub, adksetup.exe. When you run that, it will then prompt you for the additional components that you want to install, and then it will go out and download those separately. So basically, to run that stub ADK setup, you need to be internet connected in order to get the other pieces. If by chance you're trying to install this onto a lab machine where you don't have an internet connection, you can run ADK setup from an internet connected machine, telling it to just download everything, then copy all of that into your lab environment, and then run ADK setup again, and it will see that it's already downloaded everything, so it doesn't need the internet in that case. So it's a little more modular than it was before, and it does also include new tools that used to be separate downloads. Things like the AppCompat Toolkit, the Windows Performance Toolkit, those used to be separate downloads. Now they're part of the ADK. There have also been some new tools added in, the Windows Assessment Toolkit, Windows Assessment Services, much more OEM-focused tools, but could be useful for enterprise environments where you have a dedicated lab and want to do any type of performance profiling of machines to make sure that your Windows image is behaving as expected on these machines. We don't include any ARM tools in the ADK, so if you're thinking about creating your own custom images for Windows RT devices, it's not a possibility because we don't allow those devices to actually be re-imaged. So since they can't be re-imaged, it's kind of pointless to provide imaging tools for those, so you won't see any ARM tools in the ADK. You can install the ADK on any Windows 7 Server 2008 R2 or later system. It's not supported on older operating systems, and you generally shouldn't install it on the same machine as the Windows AIK. You should install one or the other. If you're going to install the ADK on a machine that currently has the AIK, uninstall the AIK first, then install the ADK. If you try to put both of them on one machine, or if you install them and uninstall them in the wrong order, you may break the ability to mount WIM files. Otherwise, everything will probably work okay. Fortunately, it's not that hard to fix the mounting problem. There is a WIM mount driver that you'll see that's installed in the ADK folders. You just need to reinstall that driver, and that'll fix up the mounting issues. As far as the tools go, we talked a little bit about what's new, but there are basically new versions of each of the tools that are added in there. We've gone from Windows PE 3.0 to Windows PE 4.0, USMT4 to USMT5. The Windows System Image Manager, which is used to edit unattend.xmls, basically hasn't changed at all between them. The DISM tool has new command line options for mounting, unmounting, image creation, Windows 8 app installation, provisioning, lots of new command line options in DISM. ImageX is still present, but in the future, ImageX will go away and DISM will take its place. So if you're used to using ImageX today, you should probably start working on getting used to the DISM syntax for doing the same thing. There is a new version of the AppCompat Toolkit included, not a separate download anymore. New version of the Volume Activation Management tool, which isn't a separate download anymore. Windows Performance Toolkit, there's a couple sessions on that one here this week. I would encourage you to check that one out. That one's useful for detecting what's causing slow Windows performance. And then the Windows Assessment Toolkit is the one that we talked about before, about having a lab environment and being able to run a set of assessments against a machine to gather information about is it performing well or is it not performing well. So the new version of Windows PE 4.0 includes new feature packs, includes .NET Framework 4.5, includes PowerShell 3.0, and a variety of PowerShell commandlets to go along with that to do things like iSCSI configuration, enhanced storage configuration, secure boot configuration, just a variety of provisioning related commandlets that go with that. So if you've done your own custom scripting or you wanted to create your own UI front ends, that always in the past required either using HTML and HTAs or writing in C++. Well, you don't have to do that anymore. You can now use .NET or PowerShell for your scripting needs, and just by adding those components into Windows PE. They do add some to the size of the boot image, but overall, it's not a drastic change. I think it goes from like 150 meg up to about 180 meg, adding these components in. So not a big overhead to add that. As we talked before, Windows PE 4.0 is required to support BitLocker pre-provisioning. It includes the managed BDE.exe and the necessary pieces behind the scenes to actually turn that on. There are some issues if you wanted to use the new version of Windows PE to run the Windows setup.exe. That won't run on the new version of Windows PE without a couple of pop-up errors saying that it can't find entry point, fast procs, whatever. You can click OK on those twice and setup will actually run, but that's kind of annoying. So if you're going to be using Windows 7 setup.exe, you want to think twice about using the new version of Windows PE. In the case of MDT in the past always used setup.exe to install the operating system. So when MDT 2012 Update 1 was released, that stopped. MDT now uses ImageX to apply the operating system. It never uses setup.exe. This is the reason. We didn't want those pop-ups to show up during the deployment. So we just decided now's the time to stop using setup.exe because we're going to have issues like this. The new version of USMT primarily adds support for Windows 8. It still does support everything back to Windows XP as a source operating system. So effectively, that means you can drop in USMT 5 as a replacement for USMT 4, and everything will work fine, as long as you're using Config Manager 2012 or later, or MDT 2012 or later, because they understand what this new tool is. Configuration Manager 2007 doesn't actually support USMT 5.0. It doesn't completely understand a couple of the minor changes in the command line options. So you would need to move to Config Manager 2012 to use the new USMT. As far as the new capabilities in there, they did add to USMT utils the ability to verify the state store, just to run a check on it to make sure that it's completely valid. They've also added the ability to extract the contents of a USMT store. So if before you had issues and you had to contact Microsoft support for them to help you get the files out of that state store, now you can do that yourself. There were some issues in USMT 4 if you specified /UE to exclude users and /UEL to say I only wanted users that have been active in the last number of days. Those didn't work very well together. With USMT 5, they've changed that behavior so that they will work together. So you could say exclude these users and exclude users who haven't logged on for more than 60 days, and it will give you the expected result. There is a blog posting that the support guys from Microsoft Support put out that go into much more detail on USMT 5, so you can read through that to see all the other little tweaks that they've made to the USMT tool. DISM we've talked a little bit about already. It does include new imaging features. It can create VHD files, it can create WIM files, it can mount them, it can unmount them, it can do all kinds of things with these files now. So as part of the process of getting rid of ImageX, all that functionality has been added. It has added some PowerShell commandlets, especially for Windows Store apps, for all those side loading operations that we talked about before. Those are basically DISM commandlets. They're just, in a lot of cases, easier to use than the DISM command lines. So you need to familiarize yourself with DISM. I had a session on Monday where we went through in excruciating detail some of the Windows ADK functionality, including DISM, just to show you all the different command line options that are out there. And DISM is a big one. Just trying to explore all the command line options and understand what's available. It's a fairly massive one. So check that one out when you're bored and like pouring through help screens. Windows Performance Toolkit. We talked a little bit about this one already. If you haven't seen any real demos of this, the sessions that happened this week, there's at least 2 of them that talk about the Windows Performance Toolkit in real-world scenarios, how they've been used to troubleshoot. Very easy to use this tool. Very easy to tell it using the xbootmgr.exe. You can tell it reboot the machine and capture a full trace of everything that happens during that boot process. The challenging part is that creates a trace file. The trace file contains all of that data. The challenging part is analyzing that trace file. So how do you dig into that trace file using the GUI tool, the Windows Performance Analyzer, to figure out where was all the time spent? So developing kind of a familiarity or an understanding of what it's showing you and how to drill into that information is really where those other sessions will help. The Windows assessment tools, we've talked a little bit about this one too. They're going to be things that you would expect OEMs to run, like make sure that the video performance is good, the network performance is good, the Internet Explorer performance is good, the machine boots in a reasonable amount of time, it goes through the post process in the required 2.2 seconds. All of those checks are written into these assessments. So the assessment tools will just run all of these assessments, gather the results, and import them into a database so that you can look at them. There are basically two scenarios. One is the Windows Assessment Toolkit, which is kind of a standalone version with a framework where you can just say, go run these assessments. The other one is Windows Assessment Services, which is more like a controller. So you have this controller sitting on top of a dedicated domain controller with Windows Deployment Services and operating system images. And it uses Pixie and Wake on LAN and other capabilities to take over a complete lab of machines. So you can tell it, turn on this machine, boot this operating system, run these tests, gather the results, repeat that with each model of machine that's in the room, and then we'll analyze the results by looking at the data that's been stored into the database. So that's a much more sophisticated tool that does require a dedicated lab environment to effectively use that. Definitely don't install Windows Assessment Services on your production network. It will take over the operation of your WDS server. It will do things to the Active Directory that it's been integrated into, so it's not a drop it into your production environment type of tool. It really is for a dedicated lab. Disk partitioning in Windows 8, if you installed the initial preview versions of Windows 8 and ran diskpart.exe, it displayed a nice message, or not nice message, depending on who you ask, saying that diskpart has been deprecated, please use PowerShell. And that caused so much of a panic that we removed the warning, because it wasn't going away now, it was going to go away with some future version of Windows, and we wanted to tell you about that years before that happened so that you could start getting used to the idea that you need to move away from diskpart and diskpart scripts and instead use PowerShell commands. So by taking out the message, that doesn't mean that we've changed the plans. Eventually it will go away, but that's not going to happen anytime soon. In the meantime, tools like Configuration Manager and MDT both continue to use diskpart.exe. But the PowerShell commandlets are useful. So if we switch over to my machine here, I can do things like get disk. Show me all the properties of all the disks that are in my system. So all the things that you could do through diskpart and really got kind of messy because you'd end up having to parse some of this stuff are much easier to do with the equivalent PowerShell commands. So if I want to get partition, I can do the same basic thing. Show me all the properties of all the partitions on my machine. So a lot of the capabilities will be much easier, and you will see tools like MDT and Configuration Manager over time shift away from a lot of the command line tools and start using these PowerShell capabilities instead. So don't think you need to do that tomorrow or the next day, but it is something to look at longer term, especially if you're going to create your own partitioning scripts. It's going to be much easier to do that in PowerShell. Roles and features is another big change in Windows 8. Actually, this one's changed between a variety of operating systems over the years, and the tools that you use to install roles and features are different between most OSs out there. Like in the case of Windows Server 2008 R2, you had to run Server Manager cmd.exe to do this, unless you were on Server Core. If you were using a Server Core install, you needed to use ocsetup.exe. But if you were using an earlier version of the OS, say Windows Server 2003, then you needed to use sysocmgr. Or if you were using Windows XP, same tool existed there. So hopefully we're done changing this now. And all of this will be provided through DISM, through the /enable feature capability, as well as using the Server Manager PowerShell module. So going forward, those would be the mechanisms that would be used. In the case of MDT 2012 Update 1, we had to completely revamp the logic because it kind of got out of hand with all the different operating systems we needed to support to make sure that we used the appropriate supported mechanism for each operating system that we support. So if we're deploying Windows Server 2012, we'll use the Server Manager PowerShell module. If we're deploying Windows 8, we'll use DISM. If we're deploying Windows 7, we'll use DISM. If we deploy Windows Vista, we'll use the equivalent in Windows Vista, which escapes me at the moment what the name of that one was. But we'll make sure that we do the right thing. If you have any custom task sequences today that you're using with Windows 7 that don't use the same mechanisms as Windows 8, well, you'll want to investigate DISM or Server Manager on the server side and move over to those. So it's fairly easy to do using DISM. You can query the system to ask what features are installed, and installing them is also reasonably straightforward. So I could say something like DISM get Windows feature. I always forget what the command line options are. So DISM online tells us what capabilities are available for the currently running operating system, and then we can see what the appropriate item is, which is just get features. And it will list all of the features and their current state for the current OS. Like in this case, I have the Telnet client installed, but I don't have the Telnet server installed. Adding it's easy enough. I just need to specify the feature name, and it will take care of installing that. And of course, I got the command line wrong again. Enable feature. The joys of DISM. So easy enough to do. A lot of the features, when they get added, this will just mark them for installation. There'll be a reboot required after this in order to support that. But if you're doing this using MDT or something like that, they're aware of those requirements. They're aware of the return codes that are set as part of this, and they'll take care of that automatically. So then we have the deployment tools, MDT 2012 Update 1 and Configuration Manager 2012 SP1. Those are the versions that fully support Windows 8 and Server 2012. MDT is still free. You can download it. The Windows 8 specific functionality that's been added is to support the Windows 80K, to provision Windows 8 applications into your image so that they automatically install for each user when they log on, to support BitLocker pre-provisioning, to install roles and features using the appropriate mechanisms that we already talked about, and to improve the UEFI support to make sure that we can deploy UEFI x86, x64 machines with Windows 8, with UEFI 2.31, just to make sure all of that works appropriately. In the case of Configuration Manager, similar type of functionality has been added. Configuration Manager 2012 SP1 requires the Windows 80K, does support the installation of Windows 8 apps via the software distribution capabilities. What you can't do is install Windows 8 apps in a task sequence. Task sequence runs as local system. Installing an app as local system wouldn't do any good. You need to install it per user. Task sequence can't run as the user, so there's no way to install an app as the user as part of a task sequence. That's something that's done after the OS is up and running, using either push deployments that target the users or using the app catalog for an enterprise app store self-service capability. Configuration Manager also adds UEFI support, so it's easy enough to push out to UEFI-enabled machines. If you look in a config manager task sequence, you'll actually see, in the MDT case, 4 different format and partition disk steps. One that runs specifically on UEFI systems that creates that 4-partition structure that we looked at. One that runs on Windows 7 or above non-UEFI systems that creates a 300 meg boot partition and the rest for the OS. One that runs on Windows Vista that creates a 2 gig boot partition and then the OS for the rest. And one that runs for Windows XP or Server 2003 that just creates 1 big partition. So you'll see those 4 steps in the task sequences to account for the differences, the needed partition structures for each operating system. So definitely try out Windows 8, download the ADK, start using that. You do need MDT 2012 Update 1. You do need Configuration Manager 2012 SP1 to support Windows 8. The boring part about this is you install those updated versions, and apart from those additional steps that you can see in the task sequence for BitLocker pre-provisioning and for UEFI support, nothing else has really changed in the deployment process. So if you're deploying Windows 7 today and you know how to deploy Windows 7, deploying Windows 8 will be really easy. There are the additional concerns around UEFI. There are the additional concerns around Windows Store apps, maybe laying out the start screen. But beyond that, Windows 8 deployment works exactly the same as Windows 7. No drastic changes compared to, say, the Windows XP to Windows 7 jump that a lot of you have gone through. So very easy to do, fairly easy to move forward once you've gotten to the necessary versions that add the incremental support that's needed for Windows 8. There are some communities out there that will help with this through myitforum.com. There is an MDT OSD mailing list where we have lots of discussions around Windows 7, Windows 8 deployments. We still cringe at the Windows XP questions that come through because we are down to the last year of Windows XP support, so hopefully most of you already have plans for moving off of Windows XP or have already done that. So that would be a good source for additional questions and answers. There's also a TechNet forum out there for MDT, also for Configuration Manager, and we also have a Facebook page where we'll post additional information about interesting topics related to OS deployment in general and MDT specifically. So check those out. And that is it. We're a little bit over time. I'll blame the woman in the alarm for doing that, but we're not too bad. So please fill out your evaluations. If you have any questions related to what we've talked about here or just OS deployment in general, come up front and we'll take care of those after the session. Thanks.